Please click on the next button to proceed.
As we get started with the Sense2GoL development kit, what you'll get from Infineon is basically a bag which contains the actual module itself, the Sense2GoL 24 gigahertz radar module, to a micro USB cable that connects to the PC, and then a USB stick containing the firmware Dave project for the Sense2GoL plus software for the GUI. You would be basically connecting the contents as shown in the picture, but basically this is how this would arrive. You'd have this USB stick. You basically would connect this to the PC, and then looking at the contents just real quick. As I open the contents of the folder, what you should see there is basically a folder for data sheets and app notes. You'll see a folder for the PCB contents, which basically contains a zip file that contains a schematic, bill of materials, and Gerber files. And then you'll have another folder for firmware, software, and the GUI, which basically contains the Dave project, as well as this quick start guide in PDF that you. So here, basically what we'll do is we'll go ahead and install this. You'll get the USB stick, as I said. You'll have a USB cable, and you'll have the actual module itself. So we'll go ahead and just plug this in and plug the micro USB to the board here. And you should see basically an LED come up like this. What's nice about this board is it's pretty compact. It's basically the BTC24 transceiver is this very small package right here, this TSNP package. The microcontrollers is basically a Cortex M0 Infineon microcontroller. And basically this is the size of the board. This other part of the board is the Sega J-Link part, which is basically used to download contents to the board or just to be used as a debugger for debugging software and interrogating the board. This back side of the board is basically the antenna side. So we have one patch antenna for transmit, one patch antenna for receive. This is basically that simple. These headers here are just going to GPIOs of the Cortex M0. So as there's a detection for motion brought out to one of these pins, and you can program these pins accordingly through the software itself. So as we go down to the next step, which is development tool installation, you'll download the contents of Dave from our internet website. Basically have to then fill out a registration and make sure you have the latest tool. The version is 4.3.2, which is what this kit operates on, that version or later. If you have a previous version, just make sure you have the latest version. You can download this through the website, infineon.com/Dave. As you download this, you basically select either 32-bit or 64-bit version of your PC that you're using, fill out a registration form, and then accept the terms and conditions, and then it'll basically download and the executable install for you on your hard drive. Once you unzip this, you will need to have administrative rights to your PC to install it on your PC. And then once that happens and you start the executable to install, you'll start installing Dave, including the library and the Sega drivers that are needed. So make sure that all the boxes are checked as you see here. And then once it starts, it'll start installing, accept the license agreements, and just keep clicking next until you're finished. Once the first part is finished for Dave, then it'll ask you to install the Sega J-Link installation and then hit next. Keep hitting next until you're basically finished. The next step is installing Micrium microprobe. We have a custom version for Infineon that is used for creating GUIs from our platforms. This is where you would be able to download the Micrium GUI from this site here. And then again, just like with Dave, you fill out the registration, accept the terms and conditions, and download onto your hard drive, run the executable, agree to the terms and conditions, keep hitting next until the installation is complete, and then hit finish. Now I go back to the next step, which is flashing and debugging. So flashing and debugging is basically nothing more than just importing a project that you're going to work with from a software point of view and then open it up in the Dave environment. From there, you can take a look at the code, modify the code, make whatever changes you want to make to it. Then you go ahead and compile and then flash it onto the board. So this is basically as simple as just importing the project. First, you have to connect the Sense2GoL kit to the computer via USB. Make sure that your debugger board is connected, which it should be if it's coming out of the bag itself. And then to import a project, what you would normally do is go to File, Import. Once you go into the import window, you will see Infineon, and then you open Infineon, go to the Dave project, import the project itself. You can import it either the folder itself, if you unzip the folder into another folder, then from there you just import the workspace, or if you just want to keep it as an archive, as a zip file, then you go ahead and just select the archive file and go ahead and install it. In the flash drive itself, you will see this particular structure where you have radar Sense2GoL _executable. You would copy this into anywhere on your C drive to make it quicker. But once you have this, you go ahead and select the directory in which you saved this under, assuming in this particular case you extracted it. And here you'll see that you have the path. Make sure that your project list is checked, and make sure that copy contents to the workspace is checked as well. Once these are checked and shown as it is here, then you go ahead and hit finish. And once you finish, you'll be able to get a window similar to this, where it shows the actual project, the application dependency, and the tree itself. So going to Dave, this is basically where I'm going to walk you through this. You go to import, as I said earlier, Infineon, Dave project. In this case, I'm going to go in a different way and just select the archive file itself. I didn't unzip it, so I'm just going to go ahead and select archive file, go to where I've saved it. It's in this folder where it says software firmware GUI. And then since I didn't unzip it, I'm just going to go ahead and double click this, and you'll see the project list here, and then copies projects into workspace is checked automatically, and then all I have to do is hit finish. So once I finish, you will start loading the project onto the Dave, and then once it's loaded, you'll see that this is basically coming up as shown earlier. The main.c file here, you'll see the libraries, you'll see the app dependency tree, you'll see the structure here, you can play with the apps itself. Just to walk through this is the main.c file where you can browse through this, make whatever changes you want to make, flip on whatever LEDs you want to have lit up as you're detecting motion, and so forth. Let's say I just want to just take the image as is and just compile it and download it onto the board. So what I would do here is the next step, which is flashing and debugging at this point. So from here, I would go ahead and just compile, go to this particular icon here, click that, and then from there, I'd build the project. And then once I build the project, it will show in the console the build project and what the size is and how long it took to build. And after building the project, I go ahead and flash onto the board, as I'm going to show you in a second here. So let's go ahead and build the project. Here we're building the project. You can see it going through the compilation here, and it took so many seconds. Here's the size of the actual code itself. So once I've built it, I'm going to go ahead and flash it, which is, in this case, let's say debugging. So I go to the debug configurations. I go to the JLink debugging section here. Automatically what comes up is the radar Sense2GoL _exe.debug. This is actually the ELF file that you will go ahead and flash onto the board. Once it's flashed, you will go right to the debug window. You can choose to stay in the other window if you want. Just to show you what the debug window looks like, this is basically it here. You'll have some buttons here. Basically what you'll do is go ahead and hit resume. It'll start running the program. And then once you run the program, you'll be basically able to see the GUI and actually see. So in order to go back to the GUI, let's see how we invoke the GUI here. We basically open the GUI by just going back to the Dave CE window and double-click the Micrium Microprobe WSPX file. And once you double-click that and select that as shown, as you have the kit connected to the computer, as it opens up, you'll hit run. That basically starts the GUI itself. You'll see as it comes up, the GUI is already created for you. You really don't have to do too much. You can customize it as you want, but as it is here, it does basically already show you the basic time domain, which is basically the raw in-phase and quadrature data that you see there. And that's the raw radar signals coming in from the IF interface. And then the spectrum itself. Since this is running Doppler, it's continuous wave. As you move faster in speed, you'll see that your frequency in the spectrum gets higher and higher. But then you basically hit run, and then from there, you'll see the actual signals moving. You'll see the spectrum. You'll see a window where it shows the speed of the movement, as well as whether or not the target is approaching or departing from the sensor. The GUI itself, as you can see here, time and frequency plots. The threshold can be set by default at 20. You could show the max frequency and speed. And again, as I said earlier, direction of movement. So let's go back to Dave. Just go back to Dave CE, and then you go here and click the WSPX file. When you do that, it opens up Micrium Microprobe. And again, this is specially licensed for Infineon, so this is downloaded from the Infineon website. Go ahead and hit run. And once you run it, hit start. I can see the movement of the actual raw data, the frequency, and I can determine whether or not the object is approaching the sensor or departing from the sensor. So in this particular case where I have the sensor, I can basically do a lot of things with it. I could evaluate it, look at the actual raw data, and then determine whether or not the object is moving away from the sensor or coming towards the sensor. A nice application for this would be basically replacing a simple PIR sensor, but with more intelligence. If I were to just want to count people coming into a room, I would place this over the door sill, and basically when people come into the room, they're basically moving away from the sensor. As they're leaving the room, they'll be coming towards the sensor and going out the door. So from that, and then if you have some higher layer software where you're actually doing some counting and doing some manipulation of the HVAC or lighting in the room based on how many people are coming to the room, it's basically controlling and sensing occupancy in a room. So that's a real inexpensive and simple way to determine occupancy in a room without actually having to track people, which is going to be a more sophisticated way of doing things. So this is a nice little tool out of the box that can do that. And you could see here as we're demonstrating just coming in, you could see the target approaching, target departing, and so forth. As I'm moving faster, you can see the speed moving up, and you can see the amplitude in the spectrum moving higher in the frequency spectrum. So that's pretty much it. If you have any questions, please contact your Infineon support people. They'll be glad to help you answer any questions. And good luck having fun with this Sense2Go.